Welcome back to the deep dive. Today, our source material is taking us into the world of infrastructure protection. We're focusing on one very specific piece of technology, the NTI E-SOD-3M outdoor oil leak detection sensor. And our mission is pretty simple.
Yeah.
We want to unpack how this thing is built to find fuel oil or diesel leaks, even when it's sitting outside in, the worst possible weather.
What's really fascinating here isn't just that it can spot oil. The real magic is its ability to, well, to ignore water. In any kind of outdoor monitoring, that's the central problem, right? Water versus oil. Think about it. Every time an older sensor sends a false alarm because of rain or snow melt, that's an emergency call-out. It's paperwork. This sensor is designed to save huge amounts of money just by winning that fight.
Okay, so let's dig into that strategy then.
Yeah.
The E-SOD-3M does this using a dual detection system. It has two separate plates. One is looking for conductive liquids, which outdoors is pretty much always just water. And the second plate is looking for non-conductive liquids. That's your oil, your diesel. It's a really smart way to separate the nuisance from the actual threat.
Right, and the logic is all built into its alarm mechanism. The alarm contact is what's called normally open.
Meaning it's off by default.
It's silent. The circuit is open. The system is programmed to only close that circuit to send that alert when a non-conductive liquid is there, the fuel.
But okay, here's the challenge that comes to my mind. If I install this and it rains, doesn't the water just sit there? Couldn't it, hide a leak happening underneath it and slow down the detection time?
That's the exact trade-off they made for reliability. The logic absolutely prioritizes avoiding false alarms over, say, an immediate reaction to a submerged leak. So if water gets there first, the system actually holds back the non-conductive leak alarm.
It waits.
It waits.
Yeah.
It will only signal an alarm once that water is gone and the fuel is what's left. It might delay things slightly in a flood, sure, but it eliminates like 99% of those costly false alarms from a sprinkler or a storm.
That makes a lot of sense for filtering out the environment. But what about sensitivity? Does this design mean it might miss small, persistent drips? Let's talk about the precision.
No, not at all. That's the other impressive part. The sensor is incredibly sensitive. It can detect a leak with a puddle depth of just 0.04 to 0.08 inches.
Wow. Okay, so that's, what, 1 to 2 millimeters?
Exactly. We're moving beyond just basic compliance here. This is about rapid intervention. Catching a spill that small means you can fix the leak before it becomes a major environmental cleanup.
And to get that kind of precision outdoors, I imagine it has to be pretty tough.
Oh, it is. The source material confirms it's IP65 rated. That means it's sealed tight against dust and even jets of water. Plus, the operating temperature range is huge. We're talking -4 all the way up to 167 degrees Fahrenheit.
And that durability, that makes sense for large-scale use.
It's critical. It runs on low-voltage DC power from NTI's main units, but the installation flexibility is key. The standard cable is about 10 feet long.
But you can extend it.
You can customize it up to 1,000 feet. Now think about a huge refinery or a pipeline. You do not want to send a technician a quarter mile across the facility just because it started raining.
Right. So when you boil it all down, this sensor is really just engineered to ignore the puddles, ignore the rain, and focus only on the real threat. It's that clever dual detection logic that ensures when you get an alert, it's real. And that translates directly to lower operating costs.
Exactly. But, thinking about how this system relies completely on the physical property of conductivity, it does raise a final provocative thought for you.
Yeah.
What if the problem isn't water? What if you're trying to monitor two different types of hazardous non-conductive liquids? Let's say pure diesel and some other non-conductive chemical solvent.
I see where you're going.
To the sensor, they both just look like non-conductive.
Yeah.
So does this sort of two-detector solution still work? Or does detection at that point require something much more complex, like some kind of chemical fingerprinting system?